Here in Chapter 17, we're going to be studying things that are not necessarily second order and see how we can use the concepts from Chapter 15 to extend to higher order equations. In Chapter 15, we solved the characteristic equation and we had two roots. They were either two real roots, they were two repeated roots, or there were two complex roots. Now, if you remember your algebra from years ago, a third degree polynomial would have exactly 3 roots, a fourth degree polynomial would have exactly 4 roots, and so on. So we're going to see how we extend this to higher order polynomials. Now we formed the characteristic equation just like we did back in Chapter 15. For example, in this first equation, we have y triple prime, third derivative, minus 8y double prime plus 37y prime minus 50y, which the characteristic equation then would be r cubed minus 8r squared plus 37r minus 50. And so you can see we form the characteristic equation in the same way we did back in Chapter 15. After we write the characteristic equation, we need to solve the characteristic equation. Now, you may remember from your college algebra days the procedures and techniques for solving higher degree polynomials. However, we're going to fudge quite a bit and utilize our Ch17 calculator, which has all of this built in. So you can see here on my Ch89, I have factored this polynomial, and it factored into r minus 2 times r squared minus 6r plus 25. So we could set each of those equal to 0 and solve. Obviously, that would give us r equals 2. Also, our Ch89 has the function csolve built into it, and we can do a csolve, C standing for complex numbers. We can do a csolve on that polynomial and get our complex roots. So here are the two complex roots and then the one real root. So from there we're able to write the solution. Now we have to kind of blend some of the things we talked about in Chapter 15. For example, what you see here is that the one real root gives us the solution c1e to the 2x. The complex roots give us the solution c1e to the 3x cosine 4x, that's the 3 and the 4 from the complex solution, and same thing with the sine, e to the 3x sine 4x. Now again, that's the 3 and the 4 from the complex solution. The characteristic equation for this one would look like this. Now we could probably do a good enough job factoring that one by hand. However, it factors on my Ch89 into r cubed and r minus 4. Obviously, that gives an r equals 0 and an r equals 4. But now the r equals 0 is a root 3 times, and so we need to make provisions for that in our solution. So here's how we would write our solution. Here's the r equals 4, And we want to do this 3 times. The r equals 0 would give us a ce to the 0x. And then, since it's duplicated, we insert x's and x squareds. On this last one, I seriously doubt that you would be solving this one by hand anytime soon without some sort of guidance as far as what the solutions should be looking like. However, armed with our TI-89, you can see here I've done a C-solve, and when you do a C-solve, it lists every one of the answers. Well, since it only lists r equals 3, and this is degree 5, I know that the 3 has to be a solution 5 times. So here's how we would write our answer. We need the e to the 3x is our initial solution, and then some constant x, e to the 3x, x squared e to the 3x, x cubed e to the 3x, and then x fourth e to the 3x.